In this video, I'm just going to be taking you through division by inspection. Now, we will have to do division by inspection, very useful technique whenever we're doing partial fractions. And the first step before you start your partial fraction is always to check that the power on your numerator is less than the power on your denominator. Okay, in this case we can see that the power on our numerator is greater, and so that requires us to do division by inspection. Okay, so how we do division by inspection is we leave our sum there and we start just by rewriting our numerator. So x cubed minus 4x squared plus 3x plus 6. We say let that equal, and we open up a bracket, and we let that equal our denominator. Okay, it's not going to run out of a bit of space here, but we'll make a plan. Okay, so we do that and we open up our first bracket. And now what we're going to do is we're just going to go term by term from left to right, highest power to lowest power. And we're going to see what do I need to times into this second bracket over here in order to get the same on both sides. So the first term is always easy. It's always what do I have to times my x squared term by to get x cubed. In this case it is just x. Right. So I've got my first term sorted. Now what I'm going to do is I'm going to see I need to get negative 4x squared there, and so ask myself what do I have. So if I look in this bracket, when I times out I have negative 4 times x gives me negative 4x squared. Okay, so that is exactly what I want over there. So I actually don't want to times in any other term with an x. So I don't want to times in a constant here. In this second bracket, okay, I'm always going to have descending powers of x. So the only thing I could add in there is a constant, and I don't want to do that because I already have my minus 4x squared. Okay. Now I've got to ask myself, I still need to get this 3x. And I look over here, when I times those together, that gives me plus 3x already. So all that's remaining is my 6. So what I do is, because I haven't covered my 6 inside these brackets by times them out, I've got to add it on the outside, plus 6. Okay. And that is my division by inspection. When I times out my my right hand side, it must give me what I have on my left hand side. So how this works is that once we've done this, what we do is we say, okay, because this term over here is equal to these two terms, I can write each of these terms over this denominator, and always this denominator, this term will cancel with my denominator. So what that would look like is that this would be equal to then x plus 6 over my denominator, x squared minus 4x plus 3. So I haven't written it very neatly. Okay, so that denominator is going to stay there, and that will just be the end of it. From here, I can start my partial fraction now by factorizing my denominator and seeing is it going to be linear or quadratic. And almost always, once you've done division, you're just going to be left with a linear partial fraction, which solves quite simply. Let's take a look at another example. So, my steps will begin the same. I start on this side by writing up my numerator. It's 5x squared. And that's going to be equal to my denominator, x squared minus 2x minus 3. Okay, and again we start from left to right. So I want 2x cubed, so x squared has got to be times with 2x. So let me just correct that. Got to be times with 2x to give me 2x cubed, so that is now done. Secondly, what I want to look at is I want to try and find a positive 5x squared. So how many x squareds do I have? Well, I've got that 2 minus 2x times 2x, which gives me negative 4x squared. And I have over here an x squared, which is going to be times by a number. Now, if I'm going to get to 5x squared, that's going to be equal to negative 4x squared plus 9x squared. So when I times these together, it's got to give me 9x. So x squared times a positive 9 is going to give me the number to cancel out with that 5. Okay, now that I've done that, I can close my bracket because I have a constant term here, and I'm always going in descending powers, so that's as far as I can go there. And what's left for me is to check what's going to be the remainder. So what's going to be left after all of this? Well, I've covered my first two terms. Now I need to find a negative x. So how many x's do I have? Well, I have here minus 6x, and I have here minus 18x. So I have a minus 24x. I want only one, so negative x is going to be equal to minus 6x minus 18x, and I'm going to have to plus 23x to get that equal to my left hand side. So what I'm going to write over here, I'll just write it below because I'm running out of space there, would be plus 23x. The final step is to find my constant term, and I see here that I actually don't have a constant term. So here minus 3 times 9 gives me negative 27, so I'm going to have to add on 27 in order to cancel that out. Again, if I go back as before, my new partial fraction will look simply like this: 2x plus 9 plus 23x plus 27 all over x squared minus 2x minus 3. You'll then separate this part and do your partial fraction there after factorizing your denominator, because now your power in your numerator is greater than your power in the denominator is greater than your power in the numerator, so you can now complete that partial fraction. One more example, exactly the same steps. My left hand side, that's my numerator, equals my right hand side. What do I times x squared by to get to x to the power of 4 is simply x squared. Now, how many x cubed terms do I have? None. Well, I don't want any there, so that's fine. How many? I need also 0 x squared terms, and at the moment I have minus 1 times x squared, so I have a negative x squared term, so this has got to cancel out with a plus 1, because I want to cancel that out. It's going to be plus 1. I can then close off my bracket and check, am I missing anything? Well, I want a negative 1, and when I times these two together, that is going to give me negative 1. So there's actually not going to be a remainder in this one. So in this case, after I've done all of that division, I'm simply actually just going to be left with x squared plus 1. And that will be the end, unless of course we are trying to factorize further using our imaginary number system, which very rarely will happen in this case. Okay. I hope that helps you to understand the concepts of division by inspection.